Hi, and welcome to problem set 31. We're going to talk about symmetry, reflections, and translations. Let's start with symmetry. You're familiar with symmetric functions because you've learned them since childhood. This is y equals x squared. It is symmetric about the y-axis because you see that the right side flips perfectly over and matches the left side. This is a function that you might not be familiar with. It is x equals y squared. This function is symmetric about the x-axis. Why? Because if you can take the top part and flip it across, you get the bottom exactly. And finally, a shape that you are very familiar with. The circle is symmetric about the origin, the point in the middle. If I take what's up here and I flip it across, I get this part. If I take this part, I can flip it across and get this part. Another example of this would be y equals x cubed. Which looks like that. You take this part and flip it around, you get that part. Now, in our lesson today, we're going to learn how to find these algebraically using numbers instead of using the graphs. So, anytime a function is symmetric about the y-axis, you should write this down. That means that f of x equals f of negative x. If I were to plug in negative x here, I would get the exact same function out. Let's try it. If I have x squared and I have negative x squared, these two are the exact same thing. For this function, we say that f of x equals negative f of x. So what that means is that if I have the y value here, it is the same as the negative y value. Now, that might be a little complicated for you. I understand. If we look at this function, we can rewrite it as y equals plus or minus the square root of x. So I have y equaling the positive value and y equaling the negative value. So this function is symmetric about the x-axis. Now with the origin, we have to pass the following test. F of x has to equal negative f of negative x. Let's try this one. F of x is just x cubed. Negative f of negative x is negative x cubed. What's negative x cubed? It is negative x cubed. And so x cubed equals x cubed. So 3 tests that you should know and include in your notes. Symmetric about y, symmetric about x, and symmetric about the origin. Next, we're going to talk about reflections. They'll seem very similar. Come join me over here. So if we are reflecting a function, the same properties apply. Just as a review, to flip something or to make it symmetric about the x-axis, that means that f of x equals negative f of x. To make something symmetric about the y-axis, that means f of x equals f of negative x. There we go. And to make something symmetric about the origin, f of x equals negative f of negative x. Now, if I wanted to flip a function, I can use these same principles. Suppose that I want to take y equals x squared, which looks like this, and flip it across the y-axis, or the x-axis, to make this function. How would I do that? Well, I remember if I want to flip something around x, I make the whole thing negative. So this function is the old function, but with a minus sign in front. If I'd like to flip something about the y-axis, I can do that by using this property to make it symmetric about the y-axis. For example, suppose I have y equals the square root of x. I would like to flip that across the y-axis here. How would I do that? Well, I see here that I need to make inside that function negative in order to flip it. So this would be y equals the square root of negative x. To flip across the x-axis, you make the entire function negative in front. To flip across the y-axis, you make the inside of the function negative. Finally, if you wanted to flip about the origin, you would make both of them negative. Let's try it. If we have y equals the square root of x, and we want to flip it about the origin, we would flip it across the x-axis and then across the y-axis. So we combine both transformations. The square root, negative square root of negative x. That flips it about the y-axis and then flips it across to the other side. So that is how you do reflections. Moving back over here, we are going to talk about translations. This is probably one of the most important topics in all of graphing, because if you can figure out translations, you can figure out much more difficult problems and simplify them down to easier, simple graphs and functions. So the trick to translation is this. If you want to translate a function up or down, you take your original function and you add or subtract some number. If we add, we will go up. If we subtract, we will go down. In this case, shift is the number that you want to shift it up or down. Let's check this out. Again, we're going to use y equals the square root of x as our example. If I want to shift the square root of x up 3 units, I would have this graph. How do I do that? I will add some number to that. What number do I add? Well, however much I shifted it up. In this case, y equals the square root of x plus 3 on the outside. If I wanted to shift that function down 3, I would subtract 3. You'll notice that every point in this function is either moved up or down. So this function moved down 3 is y equals the square root of x minus 3. To shift up, you add. To shift down, you subtract. Now moving left and right is much more complicated. To move left and right, you have to do things backwards. So to shift left, you take your original function, which was f of x, and inside the function, you will add your shift. To shift to the right, you'll take your original function and subtract the shift. To go to the left, you will add. To go to the right, you will subtract. It's backwards thinking, but it works. Again, we'll use y equals the square root of x. To shift this function 3 units to the left and get this one, I take the original function, y equals the square root of x, but instead of subtracting 3, I will add 3. That makes sense because originally when I plugged in 0, I got 0 out. Now, when I plug in -3, I still want to get 0 out. So, if I plug in -3 plus 3, I have y equals 0. So I see that this shift is successful. If I want to shift my function to the right, I will add 3. I apologize, I will subtract 3. So this function is y equals the square root of x minus 3. To shift to the left, you will add. To shift to the right, you subtract. And that is problem